Hey there, YouTube. This is Whitchurch Muthumani, and we. This is my second, video on like the robot that I was working on. Now the robot looks a little bit different. That's because we have the circular thing on top, right? The circular thing is basically called as a lidar, and you can think of, say, the lidar as laser beams that are shot by the robot in a circular, region. If there is something that falls into the circular region, like this tall, rectangular object over here, it will be reflected by the lidar, shoots the lidar, it reflects from the lidar and comes back. So when it gets reflected from the from the rectangular object and comes back, it gives information to the robot about how far this rectangular thing is from the robot's location. Alright, so now I just have this picture of what's happening inside the LiDAR. So basically, in my robot implementation, like the LiDAR is broken up into four regions, one, two, three, four. Okay, so now you see this rectangular block is in front of the robot, right? And it's located in sections two and three. So when the robot is, sending out this beam, when it reflects back, you will see numbers appearing in sectors two and three to tell the robot that, hey, there's something in front of you in sectors 2 and 3. So to see how this works, let me go back to the simulator. So here we are back in the simulator. So as you can see, the robot is sending out a beam of laser, and so the sectors are 1, 2, 3, and 4 respectively, right? So when it sends a beam of lasers, it hits something in sectors 2 and 3, and it also hits something in sectors 4. So let's see like what the lidar information says. Cool. So here is the lidar information. Okay, so you have sectors 1, 2, 3, and 4 respectively. If you look at sectors 1, there is nothing there, so there are no numbers appearing. If you look at sectors 2 and 3, so you see two numbers appearing, right? 4.1, 4.1. That's just showing that this big block is there and it's located in sectors 2 and 3 at a distance of 4.1. I think it's meters or centimeters, I don't know. And then if you look at sector 4, it's showing 4.7. Why does it show 4.7? If you look at sector 4, so here you have this circular sphere, right? So it's saying that there is a sphere and it's located at a distance of 4.7 in sector 4. That's how the lidar works. By using the lidar, the robot can do more navigation. So since now the robot knows there's something round about it based on the numbers that appear in these four sectors, namely sectors 1, 2, 3, and 4 respectively. Alright friends, let's stop talking and let's run the robot and see what happens. Alright, I'm going to launch the robot now. Boom. Hey, the simulator is loading. And cool, the robot starts. Let's have a look. Okay, the robot is getting close to that square. It's turning. Awesome. It's using the LiDAR information. Slowly turning. Let me zoom out. And it's moving. It's moving towards the wall. Okay. I think the wall is an easy thing. Cool. Approaching the wall. When it gets close enough to the wall, it turns around once again and it moves. Don't you think it's awesome? Just by using the LiDAR information, you can say how far an object is and use that to tell the robot to turn or to stop or to do whatever. It's really awesome. And the really cool thing is, this is just implemented with a bunch of functions and code. I did not even have to use a neural network for this. I did not even use like reinforcement learning. It was just done with a bunch of subroutines and logic. You can think of it as a reflex agent, and it's it is it's just working based on a bunch of rules. Okay, seems to have some difficulty, but it was able to make it through, and it's moving straight to the sphere. All right, getting close to the sphere. Beautiful, beautiful. It's able to turn when it hits the sphere and move on. Really awesome stuff, right? No neural networks were used, just subroutines and logic. This is a robot that works on reflexes, and it doesn't use deep learning or weights in the neural network to learn a policy. Of course, that would be the next step in making a robot because if you use neural networks, you can learn a more generalized policy. That'll be really awesome. So, neural networks, deep learning, and reinforcement learning should be combined together. That'll be really awesome. Cool. Now it's in a spot. Will it be able to get around this? Awesome. So the robot knew it couldn't travel in that gap in right between the sphere and the ball. So it did the most intelligent thing it could. It just avoided it. Okay. And it's going straight now. Man, I would never get tired of watching this robot just move around. Okay. All right. Awesome. What's it going to do? Okay. It's in a bind. Okay. Fine. Fine. That was a struggle. All right. All right. Awesome. Okay. It's going to another part of the map. Let's see what happens now. I want to see if my logic is able to handle this. Okay. All right. This seems easy. It's just a wall. Cool, man. Now, okay. Now it's going into this narrow pass, I think. Will it be able to travel inside this narrow pass? Yes, it is. Okay. This looks interesting, though. This region, which is like a V. Let's see what happens here. Hmm. Okay. Okay. What are you going to do now, robot? Not bad. Not bad at all. It turned. Struggles a little bit, but I'm sure it'll make it. All right. Lot of dancing and wiggling over there. Oh boy. Okay. Okay. It's in a bind. It's in a bind. Let's see if it'll be able to make it. Make it. It's struggling. I'm sure it'll make it. Yeah, that's it. It made it. All right. So let me just zoom out a little bit more. Let's see the entire world. And cool. That's it. So I hope you guys enjoyed this presentation. I really had fun making this robot. Now with the LiDAR, it's even more awesome. So that's it. Bye.